Alright, CNT120, Chapter 3, we are continuing on with IP version 4 addresses, getting some more details now. IP version 4 address is 32 bits, so again, if I write it out in binary, I would have 32 ones and zeros, but it's typically grouped into 8 bits each on octet, and each of those octets is represented by a decimal number from 0 to 255. So if I take a look, here's typically how I'm going to see an IP version 4 address. 4 decimal numbers, number, dot, number, dot, number, dot, number. Dotted decimal number is what they call that, dotted decimal number. If I actually write that out in binary, this is what I get. So if I take the number 192.168.10.48 and write it out in binary, this is what I get right here. This is actually what our network and our computers see. They actually see this binary number. Again, reminder, content page, this chapter 3, I have materials in there on conversions. Some binary conversion is valuable as I start working with IP version 4 addresses. If I'm on a Linux or Apple machine, if I use an ifconfig, I can actually see my IP address. If I'm on a Windows machine, if I use ipconfig, I can see my IP address. So let me go here to my Windows machine. I'll clear this off again. ipconfig. I can actually see, here is the, since I'm using my wireless card right now, here's the IP address. Here's the IP subnet mask and gateway for my machine right now. And we have a 10.0.0.54 address. That's what my laptop has received from the DHCP server. When IP version 4 addressing was set up back in the 80s, the internet was still something, in its infancy, if you will. The IP version 4 addresses was set up in classes. And we still do have some, this is kind of from like the dinosaur ages of the internet. However, we still see bones of this, some skeletons of this, with numbers and things we're working with today. So we still need to be aware of these classes and how they were constructed, because we still do have elements of that today that we need to focus on. The 5 classes A, B, C, D, and E were set up for MyAna. And Class A was, they basically spelled out or specified the first octet. Class B, they specified the first 2 octets. Class C, they specified the first 3 octets. D and E were set aside for special purposes. D for multicasting and E for research. Okay, so there was my 5 classes. Now, let's break these out a little bit more. Class A, again, when the internet was new, if you will, was set aside for government use. This was set aside for government use. What they did was they dictated the first octet as the network, and they left the remaining 3 octets alone and said to that government, use those how you want. So they said this first octet is identifying your network. The remaining 3 use however you want for all the hosts in your network. So with 24 bits available out here for host, 2 to the 24, because we're binary, 2 to the 24, meant that there were 16,777,214 addresses for my nodes, my hosts, my computers on my network. I would know it's a Class A by looking at the first octet. The first octet was my clue that this was a Class A network. My first octet, if it was 1 to 126, would indicate this was a Class A network. So if I saw a 50, a 70, a 92 dot something, I knew it was a Class A network. And I knew to deal with it in this manner, or recognize that it was set up in this manner. Class B was set aside for large business. What IANA did then was they said, okay, we're going to spell out the first 2 octets. We're going to dictate to you the first 2 octets to use. The remaining 2 are up to you to use how you want. They're like, hey, we will carve out the first 2 octets for you and identify them as your network. The remaining 2 octets are yours to use however you want. So those 2 octets here, 16 bits, 2 to the 16 meant that they had 65,534 possible addresses to work with to assign to hosts on their network. So again, this was set aside for large business. And I would know it's a Class B when I looked at the first octet. The first octet the number would be in a range of 128 to 191, 128 to 191. So if I saw a 130 or a 150 or 190 dot some number, I would know it's a class B, and I would know to handle it like so. First two octets were specified by Anna. The remaining two are up to that network, that user, that network to use how they need it for their nodes. Now, I do have a little reminder in here. If I look at my Class A and Class B first octet rule, I'll see that the number 127 does not show up. That's because 127.0.0.1 is our loopback address, so the 127 does not show up as a first octet. That was not assigned to any network anywhere, because 127.0.0.1 is my loopback. And real quickly, if I go to my command prompt here and do a ping at 127.0.0.1, that's pinging my loopback. That is checking to see if my NIC is functioning and TCP/IP is installed. If it is, it responds to that ping. This is very much like reaching out, installing a new doorbell in my house, reaching outside my door and pressing the doorbell to see if it works. It's me testing the doorbell. Here it's me testing my network card. Okay, that's what that is. So I won't see that in the first octet rule. I won't see that there. That's why it's not there. Class C was set aside for everybody else, and that included, your network at home. If you had a business, Hacks network, Penn State's network, all your major universities, their network. Okay, again, this was in the 80s and early 90s. So this case, IANA indicated or specified the first three octets as network. They assigned those to you, and they left this last octet alone, and they're like, hey, use this last octet however you want for the devices in your network. While there's 8 bits there, so 2 to the 8 meant we had 254 addresses to assign to hosts in our network. And in 1989, 1990, that was like, woo, that's a lot of addresses for a lot of computers. It's not today, but it was then. Okay, so I would know this was a Class C by looking at the first octet if it was in the 192 to 223 range. So if it was 198, 201, 215, I would know this is a Class C network, and I would know to treat it like so. The first 3 octets are network. The last is host for the computers on that network. So I do want to remember my first octet rules, and I do want to remember for that Class A, B, or C, whether we have, I'm going to scroll back here real quickly. With a Class A, remembering the first octet is network, the rest 3 are host. I need to remember for Class B, first 2 octets are network, the remaining 2 are host. And I need to remember that C is first 3 octets are network, the remaining is host. Those are all the normals I need to remember. Class D was set aside for multicasting. Well, real quickly, unicast is a message sent to a single node. Unicast, unicycle has 1 wheel, 1 tire. A unicast is a message going to one node, 1 device. A broadcast is a message going to all devices. Kind of like, hey, we have a sale, or hey, we're handing out free stuff over here. Hey, don't forget to, check under your bags before you leave your airplane seat. Okay, that's a message going to everybody. A multicast is a message going to a small group of things. Not one, not all, a small group. This can be used by some routing protocols to send a message just between the routers. This can also get used for things like a multimedia conference or a stream. Not everybody wants to see the live stream event of blah product released or blah device release. But people scattered around my network, one here, one there, one here, one there, may want to see the release of the new device, the new laptop, the new game console, the new game, etc. So a multicast would be a way to get a message to those handful of people. Not one, not all, those handful of people. So multicasting gets used for this purpose. And if I see a number in the first octet number in the range of 224 to 239, I know this is a multicast, and I would need to treat it as such. Class E was set aside for research, experimental research use. These never got assigned to anything, so just recognize that anything above my 239 was set aside for research use. This is showing you a breakdown of Class A, first octet, Class B, first 2 octets, Class C, first 3 octets. That's what that's showing you. Network bits over here, host bits over here. So if that kind of jogs your memory, think of that. If this jogs your memory, think of this as well. I threw a couple different options in here to help jog your memory. Now, the second piece of this is our subnet mask. Our subnet mask, as we said before, kind of decodes for us which part of the address is network, which part is host. So when I look at the subnet mask, the network or subnet piece is going to be represented as all binary ones. We often see 255 because 255 is actually 8 ones. 255 is actually 8 ones. So the network piece is going to be all ones in binary, or we typically see 255. And the host portion is going to be all zeros. All zeros in binary, or 0 in decimal for that matter. And this lets us know which part of the address is network, which part is host. So my default subnet mask for Class A is 255.0.0.0. This is the network octet. The zeros over here are the host octets. So network, host, host, host. Class B, first 2 octets were network, last 2 were host. Class C, first 3 octets were network, last one was host. Those are the default subnet masks for A, B, and C. So if I have a Class A network, here's the address, if you will, a node on that network. I'm thinking network, host, host, host. I'm thinking 255.0.0.0. That would be normal for a Class A network. If by chance I were to see a number like this guy down here, 255.224, I would know, I always joke, that smells funny, I would know something occurred. In this case, it's subnetting. Something has occurred to create a subnet piece out of this hole. If I have a Class B, here's a 150. I'm thinking network, network, host, host. First 2 octets network, last 2 host. I'm thinking 255.255.0.0. That's all my default. That's my default, my normal. If by chance I see a 255.255.240, again, it smells funny, I know subnetting has occurred. That third octet is being used to create subnets. If I have a Class C, 210 over here, I'm thinking network, 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 host. I'm thinking default 255.255.255.0. That's normal. It's indicating network, 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 host. If by chance I were to see a 255.255.255.248, I would know, again, smells funny, yes, subnetting has occurred. They've used this last octet and broken into some pieces to create subnets. So I need to remember my defaults so that I know when these special things come up. With IPv4 addressing, we also have a couple special numbers. A node address would be something like this. This is identifying a specific node on the network, kind of like 123 Main Street, Mechanicsburg, PA, as opposed to 123 Main Street, Lima, Ohio kind of thing. When I have 0 in the host portion, that's identifying the network. So this would be 192.168.10.0 is identifying the network. Example, Main Street, Mechanicsburg, PA. You notice the house number 1 away. It's identifying the network. It's identifying the street address, if you will. Again, Main Street, Mechanicsburg, PA, as opposed to Main Street, Lima, Ohio. The last special one that's down here is 192.168.10.255. 255 out here is a broadcast address. When the host octet goes to all ones, or 255, that's a way to send a message to everybody in this particular network. So this would be a way to say, hey, does anybody know where this thing is? Hey, does anybody know where this server is? Hey, does anybody know where this computer is? That's a way to get a message to everybody on that network. We need to remember these network numbers and broadcasts because they are set aside for those special purposes. We don't use them for anything else other than to identify the network or to broadcast to the network. We need to remember those. Here's our couple other special addresses that we have. Here was the PIPA. Here was our loopback. Here was the broadcast and all of our zeros.